Hello, welcome to the second C# tutorial in the series. This one is going to be about things called variables. So, a variable is just something that can store something else in it. That's all it is. It doesn't matter what it's storing in it, it's just storing something. It can be anything. The first kind you're going to learn about are called integers, which if you pay attention or know like any math, you'll know what they are. It is just a number that does not have a decimal point and is rational. I don't think there's any rational. Anyway, so to create an integer or any variable, you have to type the type name. For an integer, you just type int or int. Then whatever you want to name it, we're going to call x because everybody loves a good x. And then you type a semicolon, and now it will create your variable called x. You can run this program. Nothing actually happens, but you can run this program. And yeah, congratulations, you made your first variable. That's not very useful. So what you do is, something else that's very helpful is if you leave the semicolon, then you can type equals, and then whatever you want it to be equal to. I'm going to choose 54 because that's a fun number. And now you can compile this, and you can run this as well, and you'll notice that it does equally little. However, now x is 54, whereas if you didn't initialize it, you don't really have any control over it. Now, okay. So now, you're probably wondering, well, what can we do with variables? Well, you can access them using the same output we did last time, except for you'll notice this time we don't put quotes around it. If you put quotes around it, you just get x. It'll print out x. It won't print out like whatever is in x. And to do that, you do not put quotes around it, and then we realize that x is a variable, and it wants to print out the value of x. Whenever you type x, it will be like, oh, clearly he wants the value of x, and he doesn't want to say the letter x, which is what this would say, or what this would say. So now when you do this, you'll see it prints out 54. Also, quick fix for that, so we'll have it for a little bit longer. Don't worry about that for any amount of time. See, now you'll see it says 54. Hooray, it works. But you're probably thinking that's not very useful. Like x is 54, hooray. You're probably thinking, I could have just written 54. Or you actually could have just written 54 like this too, and would still print on 54. However, the variables are very, very useful. I'm sure a lot of people probably realize that, but I figured I'd say that anyway. So also you can naturally assign variables to other values without writing int x now, because if you do write this, as somebody may have tried, it gives you an error. It says a local variable named x is already defined in the scope. Pretty much all that means is there is already a variable called x, or there is already an x. You can't have two of the same name. So if you wanted to, you could do int y equals 15,278, and then it would be okay with that. You could compile it, and notice it doesn't have an issue with that. It does give you a warning, but you can ignore that warning. You can also type, if you want to reassign x, you don't type int x, you just type x equals 128, I guess, and then when you run this, it'll give you 128 instead. And another thing you can do is you can do this, and then it will give you 54, and then 128. And now you know that's actually working. So, they're very useful to just store things, but you can also do math on them. So I can do 128 times 2, for example, and then it will give me 256. You can also do math in here. So if I were to write times 4, this should give me 1024, and it does. So because whenever you use a variable like this, it's essentially saying, what is the value of x, and then replace this x with whatever its value is. So if we trace it, if we run the program in our heads, which is something that is good to be able to do, you have x equals 54. So now you're thinking in your head, oh, okay, now it's 54. Then you have x equals 128 times 2. You're like, oh, okay, now x is 256. Now when you see the x here, you just replace it with 256, and you're like, I wonder 256 times 4 is 1024, and I would expect it to write out 1024, and it does. So whenever you access variables, just think of it as it's replacing the variable name with whatever the value is. However, you can also get back our trusty old y in some number. Wow, that's actually pretty good. It's the same digits I used last time. It's not in the same order. Anyway, You can also assign variables to other variables. So if I do write x equals y, that's like writing x equals 12587, except for not quite so lengthy. And now you'll notice it'll print out, well, it'll print out 12587 times 4, which is 50,348. Or you could do y equals x plus 4, or let's do divided by 6, because that's a fun math problem. And then it'll give you that, which is roughly correct. If you plug it into your calculator, you might notice that it's not exactly correct. It's probably a little bit off. Whoops, that should be divided by 6 times 4. It is a little off, because when you run the program, it says 8388, not 8391, which is what it should say if it was doing it completely accurately. The reason for that is because they're integers, so it can't handle decimal points, so it always rounds down. It's not really a detail, it's very important, but I'm sure you'll run into it later. So anyway, thanks for watching, and